All right, I am recording my final for stats, intro to stats, and here is my Bearcat card. My M number is M04297649, and I've actually changed my name since I've gotten married. It's actually Kelsey Justice now, so I'm not sure if you need to see my face for in the video, but there's that. So I'm gonna go ahead and jump into it. Sorry, my work's a little messy, but I don't have a printer, so I'll have to go to the library and all that good stuff, and you need this video soon, so I'm just gonna go ahead and record it. So question number 1, in this study, 2 independent random samples with interval ratio data were collected. In group 1, a random sample of 133 primary hypertension patients were taken, and each person's total cholesterol was recorded. In group 2, a random sample of 41 normotensive was taken and their total cholesterol was recorded. Data are given in the table below. Use the 5-step hypothesis testing process to check if the PH group's population average total cholesterol level is significantly higher than 210. And our alpha is 5%. So, given that, we are given our sample mean, which is 214.71, which we can, given there in our table. Our sample size is going to be our 133, and then our population variance is the 879.47. So that's all given to us in this table. So what we're going to do first is we're going to test the hypothesis. So the null hypothesis, we're just seeing if it's equal to 210, and the alternative hypothesis if it's greater than 210. So we need to test these. So basically, we are just checking to see if it's higher than 210, and based on step 1, we can determine that this is a right-tailed test. That'll be a 1 right-tailed test, and let's see, so what else did I write here? For which a z-test for 1 mean population standard deviation will be used. Yeah. Based on the info that's given to us, the significance level is 0.05, and the critical value to match with the 0.05 would be 1.64. So the way I figured that out is, you have your 5%, so you need to use your z-table. And so what you want to do is, I would say the middle here, so like right down the middle would be in between 0.4 and 5. And then the middle of the z-table column, because you're looking for dead center, because 0.5 is right in the dead center. So 1.6 corresponds, let's see, so 1.6 responds to 1.45. Let's see up at the top, 1.45, 1.6, which is just dead center of our data. So I'm thinking 1.64 would be the correspondence with the 0.05 significance level. So now we need to test our statistics here. So we need to figure out if our sample mean, so that basically we have to use this formula. And sample mean, you punch in the sample mean minus the population mean over the standard deviation divided by the total number. So that's when we punch in here. We get our 214.71 from up here from our chart. We're going to minus our 210, which is the cholesterol, the level. We want to we're seeing if it's significantly higher. So that's where we get the 210. And then our standard deviation of 29.66, and we put that over our total population, our total number, of 133. And that gives us our 1.83. So we can finally test, we can observe that the 1.83.1 is significantly larger than our critical value of 1.64. So it is concluded that the null hypothesis is rejected because it's larger. So we can also use a p-value approach. I'm not going to go too deep into that because we use the test statistic, but basically our p-value is 0.0335 and 0.335 is smaller. 0.05 is significantly larger. We can also conclude that the null hypothesis is rejected because we said it was equal to. So basically, to conclude up question number 1, to sum up, I should say, conclude, it's concluded that the null hypothesis is rejected. Therefore, there is enough evidence to claim the population mean is greater than 210 at the 0.05 significance level. So hopefully you're able to understand that, and we're on to the next question.